Hey, OChemsters, this is Mrs. Mandel. I bring you the last section in Chapter 7. We're talking still about alcohols, and these are alcohols with more than one hydroxyl group. I find this section pretty interesting because it really talks about some of these properties and some of these things we've been dealing with in this chapter, all right? So the very first one I'm sure you all have in your maybe your garage someplace, and that's going to be ethylene glycol. All right, and ethylene glycol, here, let me scroll down. That is the common name. The IUPAC name, well, how would you name it? All right, we have two alcohol groups, so we call the diol, so it's 1,2-ethane diol. And the boiling point of this is 198 degrees Celsius. All right, so what is its use? It is antifreeze. You put it in your car, all right? So during the cold weather, hopefully things in your car doesn't freeze up, all right? Because of its properties where it increases the boiling point, it will also decrease the freezing point, all right? That's your ethylene glycol. One other use for ethylene glycol is that it's helped to use in polyesters. And we're going to see that a little bit later down on this page, all right, where you would use a glycol to make polyesters. The next one is also very interesting. This is propylene glycol. All right, there is propylene glycol. How do you think you would name it if you were doing the IUPAC name? Go for it. All right, I have 1,2,3 propane triol. And notice its boiling point's even higher. All right, why do you think the boiling point's even higher than ethylene glycol? Well, you have another OH group. So you have more places for hydrogen bonding to occur so that you have more attraction. Therefore, it takes more energy to pull apart. All right. What is propylene glycol used for? Now think about this, all right? It's used as as a food additive. You may be eating some of this stuff, all right? Well, why would they add this to food? All right, it helps to preserve moisture. Think about that. Why would they use propylene glycol, which they consider safe for consumption, to be used to preserve moisture? You have three OH groups here. What do you think it's going to do to the water? Is it going to attract the water to it? So if it's going to attract the water to it, that means the water is less likely to leave. It preserves moisture. All right. It's also used to dissolve colors and flavors. Why would it be used to dissolve flavors and colors? Because of the OH groups. Just like water would do that, so can this. Oh my goodness. That is a property of alcohols, isn't it? Yes, you can dissolve water with alcohol. You can dissolve other things in alcohol. So, yes. Now, what about this thing? I don't know. Some of you may not have ever had sorbitol before. I would hope you wouldn't need to use it, all right? So take a minute out and write down what you think the IUPAC name would be. All right, this is kind of weird. All right, it is 1, 2, 3, 4, 5, 6 hexane hexol. I think sorbitol is a little bit easier. And look at this. We don't even talk about its boiling point. Let's talk about its melting point. All right. So it takes even more energy to melt a solid. So it's 120 degrees C. All right. So it's a solid 20 degrees after water will boil. So what is this used for? Like I said, I hope that some of you would not have had a reason to have sorbitol, but it's used as a laxative. Why do you think it's used as a laxative? What do you think all these OHs are going to do? All right, it's going to draw the water to the sorbitol. All right, so if it's going to draw water to the sorbitol, it's going to make well, you know what I'm trying to say, a little bit softer and easier to come out. Okay, so I guess I can say the word feces on the video here. So it's going to make your feces softer and easy to come out. Why would they be softer? Because it's bringing in the water to this, laxative, and hopefully that will help things flow a little bit easier for you if you get my drift. All right, let's go down to the reactions. All right, so glycerol, which has those three carbons, notice I wrote it this way instead of, going across. Instead of horizontally, I wrote it vertically, all right? Why would I do that? Well, let me show you why. Glycerol reacts with nitric acid, all right, which I'm going to rewrite as HONO2, all right? So it can react with one here and one here, and whoops, sorry about that, and one here. All right, so why would I do that? Well, what can we do? Oh, if you can make water, you will make water. Oh, yeah. And here I go. So notice how I drew my box. Why would I draw my box this way? I see an H and an O here and an H and an O here. Why does the H have to come from the nitric what? Nitric acid. What does an acid do? An acid donates an H plus, all right? Folks, don't do this. The alcohol is not an acid when you're with a strong acid, all right? So in this case, the alcohol acts like a base, okay? Acts like a base and accepts the H plus from the nitric acid, okay? So then what am I left with? I'm left with this and then 3 waters, okay? So why did I write it as HONO2? So that it's the oxygen that's bonding with the carbon, not a nitrogen, all right? Nitrogen cannot handle 4 bonds. It's not going to do that, all right? Now, this is also kind of cool stuff, all right? All right. Glycerol can also react with carboxylic acids to produce what? Large esters, okay? So watch this. All right, so carboxylic acid, that's your C double bond O, OH. That's your C double bond O, OH. Let me do something real quick because I'm getting a little crowded. That's why I had to draw these C's and O's, a little bit large so that I'd have room for the C double bond O, OH. All right, let me get the next one in here. All right, and here I go. So once again, if you what? Can make water, you will. All right, if you can make water, you will. Once again, I'm being very deliberate on which H and which OH I am using, all right? If this is a carboxylic what? A carboxylic acid, what does that mean? It means that it's going to donate the proton. Even there's an O here, could the H from the alcohol donate it to the acid? No, acids do not accept H pluses. Acids will donate its H plus, okay? So hopefully that makes sense to you. We're gonna address that a little bit down the road. But for right now, understand that if an alcohol is with an acid, the alcohol will act as the base, okay? I'll say that again. If an alcohol is with a stronger acid, which really anything is labeled as an acid is a stronger acid, then the alcohol will act as a base. Keep that in mind. So then what do I get? I get a big, huge chunk of something. All right, I get this. All right, plus water. Now, what did I tell you make here? You make, let me make this a little bit bigger here. Well, that didn't work. Oh, well. Let me try one more thing. Nope, still didn't work. Okay, this CO, C double bond O is an ester group, okay? You should know that by now, okay? I gave you that list to start memorizing. So this is your ester group, okay? Here is an ester group. Here is an ester group. Are you circling these for me? All right, so what happens if you have many esters? Well, it looks like to me you have a polyester. All right, so depending on what this group is, how many carbons you have here, and depends on how many carbons you have off of here, all right, depends on the type of polyester ester that you have, okay? So do you remember what I told you back up here with the, I think it was the ethylene glycol? All right, it is used in making certain polyesters. Yeah, I told you that, didn't I? All right, so what if I use this one, glycerol? Now I do have another polyester, but depending on how long this chain is, listen to me carefully. If there are 20-something carbons at the end of the carboxylic acid, all right, then you are approaching what a fat would look like. So can you imagine how long this would be, all right, if I have 20 or so carbons trailing at the end here? That's a really large molecule, isn't it? All right, that would be the classification of a fat, or more appropriately, a lipid. Okay, that's what we call it, like in biochem, would be a lipid. So anyway, these are very important structures in your everyday living, really. Okay, so think about that. That's why we talk about those properties, so you can start, thinking about how this is actually in your everyday life. So I find this stuff fascinating. Can you tell? So anyway, I'm going to leave this here, and we are done with chapter 7. Chapter 8 deals with ethers. You're in the same packet. So wait for next time to start your ether conversation, okay? Don't wait to be great. We'll see you next time. Bye-bye.